So that means I'm going to be showing you like 10 different types of examples on proving identities. Guys, I'm trying to break them down step by step and trying to explain everything as much as I can. So please follow the steps clearly. Practice, guys. It requires a lot of practice to get better at these things, but it is very important, not just like for the trig course or for this trig section, but it's important for any student who's trying to pursue something in mathematics or sciences, to know and to be confident with proving identities. Okay, so again, look at this one. Same thing that is happening in all these examples is like there's more room for simplification on the left hand side than the right hand side. So we're going to start with the left hand side here as well. If you look at the left hand side, there's the sign of the sum and the sign of the difference, and obviously that already like kind of gives us a hint that we should try to go back and look at the formula sheet, or if you remember it, and write the formula for the sign of the sum or the sign of the difference. We'll start with that, and then we'll go from there and see what other mathematical algebraic principles, tools we can use to simplify that left hand side and make it look like the right hand side. Okay, so let's see. We have left hand side, and I'm going to write the formula for this. It's sine of alpha. Guys, this is going to take us a lot of space, so let's see how far we can go from this on this video. Sine alpha cosine beta, right? And then there is plus cosine alpha, and then sine beta, right? I'm using the formula for the sign of the sum, then times. There's a times here, or we don't have to really write it, but we understand there's already a times here. And then sign of the difference. Sign of the difference is sine of alpha, cosine of beta, and then minus. With sign of sum and difference, we are consistent with the right hand side as far as the sign goes. Minus cosine of alpha and sine of beta. Okay, guys, this is going to be some work, but let's try to do it carefully. So we have a lot of terms, two terms here and another two terms. Of course, there's multiplying sine alpha and cosine beta, so there's a lot of terms here. Guys, once we have it, again, just looking at this, it seems like this is not simplified and this does not look anywhere like the right hand side, but this one thing that you can see from the right hand side, that the right hand side is the difference of two terms. And here there's so much going on. First of all, is the product, and there's so many terms. So to make it, like, our goal is to make this or transform this or condense this into two terms. In order to do that, like, the only way, I would say that the only way to actually start doing it is by actually multiplying it out, which means just whether using the distribution or FOIL, however you want to do it, and let us do it, let us distribute things and let's see what we get. So again, this times this and this times this and so on and so forth. So sine alpha times sine alpha is going to give me sine square alpha. Cosine beta times cosine beta will give me cosine square beta. Right, that takes care of the first term. Then this times this one. So it's minus, and let's see what we have here. Oh, I have a lot of terms. I have sine alpha, sine beta, cosine alpha, cosine beta. I cannot really simplify them, so I just have to write everything. So it is sine alpha, cosine beta, cosine alpha, sine beta. Okay, because we cannot really simplify them, so we just got to write them like that. Let us move on to the next one. Guys, plus, then we've got to take care of this, then this times this as well. So cosine alpha, sine beta, sine alpha, cosine beta. So again, there's no room for simplification. You just have to write it out. So it's cosine alpha, sine beta, and sine alpha, cosine beta. Okay, and then the last term is minus. Let me write it over here. This is a plus, this is a minus, so I'm going to be left with a minus there. Guys, I'm trying to do everything carefully, and that's what you have to do when you are doing something which is a little more work. I have cosine alpha times cosine alpha. I mean, it's not too difficult, but you have to write the steps carefully. Okay, sine beta times sine beta is sine square beta. Okay, we have four terms. We still know, we don't want four terms. We want to somehow condense it into two terms. But wait a minute now. Let us see if there is possibility for us to combine any like terms, and if there are any like terms. Well, this guy right here, sine alpha, cosine beta, sine beta, cosine alpha, sine beta, cosine beta. It looks like they are like terms, but this has a minus sign, this is a plus sign. So what's going to happen to them? they're going to simply cross out. So we're going to cross these out because they were like terms with opposite signs, so we just crossed them out. Okay, so that really makes life a little easier for us. So let us just write what is left. So what is left is sine squared alpha, and then there is a cosine squared beta. We got to write that as well. And then there's a minus, and this guy I'm going to write, I can write sine squared beta first, and then I'm going to write the cosine squared alpha. And what made me write this first was like I looked at the right hand side, and from the right hand side I have sine squared alpha minus sine squared beta. So that's why I wrote sine squared alpha here first and cosine squared beta here first. Okay, but this still does not look like that. I mean, we're getting closer, but it still does not look like that. So we still have to do something more in order to make this look like, make this guy look like that. Okay, so there's one thing that we know looking at the right hand side. The right hand side is only in terms of the signs. Okay, there's the clue for me. There's the clue that I need. In this, when I look at this side, the left hand side, I don't want a cosine, I don't want this cosine. So what I have to do is, whenever I see a cosine, I want to rewrite that cosine in terms of the sine, if possible, and then try to simplify and see if we can finally get that right hand side. Okay, so guys, the same thing that I have been telling you in my previous videos as well. Once you start simplifying the left hand side and you get to a point where you see like there is a lot of similarities with the left, what we have, and the right hand side, but it's not like it does not exactly look like the right hand side, then you look at the right hand side carefully, and that gives you a clue. There's your clue that what I should do or what I can do with the left hand side. In this case, there's only sines on the right hand side. So here we have cosine, so we better convert them or change them or rewrite them in terms of the signs. Fortunately for us, we can do that. Let us do that and see where it leads us to. Okay, so this is going to look like sine squared alpha, and the cosine squared beta can be written in terms of the sine squared beta as 1 minus sine squared beta. Again, the same old, the very basic Pythagorean trig identity, sine squared theta plus cosine squared theta is 1. And you can solve for the cosine squared theta from there. That's what we did here. And then guys, there's minus, and I have sine squared beta. I'm not going to change this, but the cosine squared alpha, I'm going to again rewrite this as, so look like a 2. Okay, I'm going to rewrite this as 1 minus sine squared alpha. Okay. Obviously, we don't want all these terms. We just want 2 terms, right? Separated by a negative, which is, there's a negative here, but we don't want all so many terms. So obviously, we want to simplify this, which means we want to distribute again. Again, guys, as I'm showing you these different examples. If you can come up with an easier or like a quicker way of simplifying, please go ahead and do that. And just share it with me as well. I would be happy to see other methods as well. Okay. But this is what I feel like is going to be the one of the methods to simplifying this. So I'm showing you this method. Okay. So when I simplify this, this is sine squared alpha minus. Then when I distribute this, this is sine squared alpha, sine squared beta. Right. Nothing really difficult about it. I'm just multiplying, distributing this, and then minus sine squared beta, and then this minus negative times negative will become positive. Sine squared beta. Guys, I can already see like what sometimes I like to think of, like I can already see the light here, because see, and what I mean by that is like there's this and this term is going to go away because there's a minus here, there's a plus here, and they are the same terms. This is written like sine beta first and sine alpha next, but it does not matter as long as they are multiplied. So these terms basically are the same terms, opposite signs, they cross out. And what I have here, you can see like I'm so happy that we just simply got it. So that's why this is one of my favorite things, because guys, it kind of gives me that satisfaction, because here I'm able to like work. I start working with one of the sides, and then I do all the work, and finally I make it look like the other side, and I already have like, then it gives me that satisfaction that oh, I did it. I made it look like the other side. So it like just gives me that spontaneous or instantaneous like a kick. Okay, I did that work, and now I made it look like the right hand side. So that's how I feel about these proving identities. I really enjoy doing them. So here it is, number 7 is done. I'm still going to show you 3 more before we move on to the next sections. Okay, guys, till then, take care, keep practicing. You have